right, 3.5, zeros of a polynomial, day one. So the first thing I seem to have highlighted is number 3. At what points do the graph of x cubed minus 2x squared minus 16x plus 20 and g of x equals negative 12 intersect? You are supposed to do this one by hand. Not meant to be a calculator problem. So they intersect when they're equal. Like, that's what it even says in the text. You know, if you think about the graphs intersecting, that's where they have the same y value. So we're just going to set these two things equal to each other. That's substitution or transitive property. And then I reckon we'll shift left because, you know, that's just kind of what we do when we're in doubt. 20 plus 12 being 32. The reason we're shifting left and setting equal to 0 is because I'm quite confident this thing factors. If you look at the first two terms, you'll notice they both possess x squared. And if you pull an x squared from x cubed, you have an x. If you pull it from a negative 2x squared, you have a negative 2. And remember I told you if you saw four terms in my room, it was probably factoring by grouping. And it is, because if I put a negative 16 here, I would have negative 16x plus 32. So the common factor between these two pieces is x minus 2, and the stuff left over is x squared minus 16. But wait, there's more. X squared minus 16 factors. Yes, it does. It factors as x minus 4 times x plus 4. You should have figured out that special pattern by now because you've done so many of these. So our x values are 2, 4, negative 4 by using ZPP. That's by the zero product property. Think about setting every factor equal to 0. X minus 2 is 0 and so forth. Now it says points, aka ordered pairs. When you set something equal to 0, this is the y value. The y value is 0. So each of these happen when y is 0. Ta-da! There you go, kids. Not hard. It's really not. All right, sketch the, of course, that's actually not right in the original context, but it does it algebraically. Sketch the graph by finding the zeros, the y-intercept, the x-intercept, and the end behavior, think power function, of the equations shown. I have number 5 highlighted. Your zeros, you should be able to pick up pretty quick. It should also say multiplicity. Yeah, it needs to talk about multiplicity. It does. So your zeros are pretty simple. They're x equals negative 3, 1, and 4. Now, the negative 3 has a multiplicity of 1. We cross the x-axis. The 1 has a multiplicity of 1. We also cross the x-axis. And then the 4 has a multiplicity of 2. We touch. Your y-intercept is found by letting x be 0. You do some math here. You got a 3, a negative 1, and a negative 2. That makes 6 when you multiply them together. You have a 4 that gets squared. That's 16. And 6 times 16, I'm pretty sure, is 96. So you have a y-intercept at 0 and 96. Crazy, huh? You'll just have to, you know, pick a spot and call it negative 96. Or sorry, that's the wrong place. You'll just have to pick a spot up high and just call it 96. Because it's just so high. Now, let me double check my math. 0 plus 3 is 3, times negative 2 is negative 6. This is negative 1, that makes 6. 4 squared is 16, and I'm good with that. Your x-intercepts came from your zeros, so your x-intercepts were 0, negative 3, 0, 1, and 0, 4. So 0, negative 3, I don't know why I wrote it like that. My God, I am tired, apparently. I completely just like had dyslexia there. I got my x's and y's confused. Bad math teacher. Horrible math teacher. All right, that looks better. Negative 3, 0, 1, 0, and then 4, 0. Now, the power function you get by doing near math. That's what it is. It's near math. I'm going to grab this negative 2. I'm going to grab that x. I'm going to grab that x. I'm going to grab this x squared because this squared component. If we did a whole bunch of work, the power function would be negative 2x to the 4th, which, by the way, that is a negative x to the even. She starts low and she ends low. So I already know that this graph's going to shoot down towards negative infinity on the left and the right. Negative 3 was a crossing point, so I'm going to cross the x-axis. 1 was a crossing point. I'm going to cross the x-axis, so I had to curve down towards it. The 4 is a touch, so I'm going to head towards it and then bounce off of it, like that. And there's my graph. They're not hard. They're really not. Moving forward with my life, find the zeros of the function and describe the behavior of the graph at each zero. Do this by factoring. And this one is a factoring by grouping problem. The other two are not. I looked at those terms and I decided really quickly that they both possessed an x squared. If I pull it from x cubed, I have an x. If I pull it from negative x squared, I have the negative 1. I know that I can pull a negative 25 from both of these pieces and create the x minus 1 again. So the common factor between those two pieces is the x minus 1, and the stuff left over is x squared minus 25. But wait, there's more. X squared minus 25 factors as x minus 5 and x plus 5. Now, remember, multiplicity is determined by the exponent on the factor, and each one of those factors has an understood 1 for an exponent. So your zeros are x equals 1, 5, and negative 5, and they all have multiplicity of 1, which means they all cross. I don't know why my board's not keeping up with me. It's like one of my students. The x-axis. Apparently I'm too fast for a computer too. Let's see, 9 was not highlighted, 10 was. What are the real and complex zeros of the polynomial as shown in the graph? Use these zeros to completely factor this thing over the complex number system. So I've given you 3 of the zeros. Your 3 zeros are x equals negative 1, 0, and 1, and they all cross, which means they have a multiplicity of at least 1. They could also happen 3 times or 5 times. We're going to find out, okay? We're going to find out. We're going to use a little synthetic division, and we're going to divide each of those 3 things out. I'm just going to start with the 0 because 0 is small. And the coefficients would be 1. Notice the gap here. There's no x to the 6th. I need the 0. There's an x to the 5th. There's no x to the 4th. I need a placeholder. There's an x cubed, and it's negative. There is no x squared. There is an x, and there's also, at the end, there's no constant. So I need to have a 0 there for that placeholder, or this is going to go wrong. That's one that gets kids when the constant's not there. I'm almost certain it's gotten me a time or two. So, anyways, your acronym for synthetic division was DMA. We're going to drop the 1. 0 times anything is 0. We're going to add 0 and 0 and get 0. 0 times 0 is still 0. 2 plus 0 is 2. 0 times 2 is 0. 0 plus 0 is 0. 0 times 0 is 0. 0 plus negative 1 is negative 1. 0 times negative 1 is 0. 0 plus 0 is 0. 0 times 0 is 0. 0 plus negative 2 is negative 2. 0 times 0 is 0. Whew, I don't think I took a breath that whole time. And 0 plus 0 is 0. This time I'm going to go after the 1. Drop the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 2 times 1 is 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. Negative 1 plus 3 is 2. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. And 2 plus a negative 2 is a 0. And I just keep going, Because if I have a remainder of 0, and I doubt you remember it, you just keep doing what you're doing. Good stuff, bruh. Good stuff. All right, now we're going to do the negative one. We're going to drop. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 0 is 0. 3 plus 0 is 3. Negative 1 times 3 is negative 3. 3 plus negative 3 is 0. 1 negative 1 times 0 is 0. 2 plus 0 is 2. Negative 1 times 2 is negative 2. And negative 2 plus a negative 2 is a 0. That was fun. That was fun. Remainder, constant, x squared, x cubed, x to the 4th. Let's see what we have here. We have x to the 4th plus 3x squared plus 2. And there's 4 zeros there. So we're just going to try and invoke the zero product property. Set it equal to 0. Factor. Factoring is freaking awesome. Takes an x squared and an x squared to create an x to the 4th. Factors of 2 are simply 1 and 2. And it works because the outside is going to make 2x squared, and the inside is going to make a singular x squared, and x squared plus 2x squared is 3x squared. And, you know, maybe some of y'all know how this works by now, maybe some of you don't. It'd be cool if you did. X squared plus 1 is a 0, x squared is negative 1, x is the plus or minus the root of negative 1, which is plus or minus I. All right, next one. X squared plus 2 is 0. X squared is negative 2. X is plus or minus the imaginary root of 2. And you're supposed to factor this over the complex number system, which means real plus imaginary. So let's look at all of our zeros. This was a 0. The factor is x plus 1. This was a 0. The factor is x. This was a 0. The factor is x minus 1. Those are the 3 real ones. Now, if x equals negative I, x plus I is the factor. We just changed signs. So we have an x plus an I. We also had an x equals a positive I, which is x minus I. Here we have plus or minus the imaginary root of 2, so one of them is x minus the imaginary root of 2, and the other is x plus the imaginary root of 2. Pay attention to these relationships. Conjugates, conjugates. Complex, funny answers always happen in conjugate pairs. All right, good times. And that's it. That's all your homework I'm doing. I did the hardest one on there for you. You are very, very welcome. Hope you learned something.